First of all, I was wondering if I could ask a tiny favor, because I travel sometimes to conferences and do presentations, but my mother never believes that I do. So every time I go to a conference to do a presentation, she thinks that I'm at home playing computer games and just talking about it. So I was wondering if it is okay that I take a picture that I can send to her. Is that okay? If anyone doesn't want to be on the picture, I can assure you I will not put it on social media. I will only send it to my mom. Okay. All right, let's go. Thank you so much. And thank you, Wienerberger, for inviting me to the Future BIM Conference. It's great to be back in Vienna. I will talk about what I do for a living, what I've dedicated my life to doing, which is BIM hacking. And I think and believe that this will change everything in the building industry, which is kind of a bold statement, no? So, Mr. Vasshaug, do you have any numbers to support your theory? And let's crank into the material then. For me, BIM hacking started with something like this. I worked with BIM since the beginning of this century, and it was always a painful experience for me to try to make BIM do what I wanted to do as a designer, but it was impossible for me because BIM was created to do like very specific things. Sometime around 2011, actually this is probably exactly 10 years ago, it was in November 2011, two Americans, Zach Krohn and Matt Jasek, went on stage on a similar venue like this in Las Vegas and presented this. This is a tool called Dynamo that lets you hack Revit, which is a BIM creation platform. Exactly 10 years ago. The guy who made this, he worked at an engineering firm called Bureau Happold in New York City, and he was highly inspired by a tool called Grasshopper that was created by a guy called David Rutten that actually I think lives in Austria. And it's all about creating a low threshold way for anyone to become a hacker of their own tools. Sometimes I talk to people who are already programming and have been programming for 30, 40, 50 years, and they don't get very impressed when I talk about the future of BIM as, programming your own tools, because they always did it. But what is changing now is that this is becoming mainstream. It's becoming big. We're not talking about 50 people globally or some guy in a dusty corner doing this and not talking to anyone about it. It's a movement. And it all started here with boxes, with input, mathematics in the middle, and then output at the end. And then you run a script and you see things happening on the computer automatically, and it's a great feeling. And it is the future of BIM, I think. Some numbers to support this. I am presenting now the data scientist, Mr. Vasshaug, who has found a really interesting way of connecting PowerPoint with Excel. So I have some numbers in Excel and they become lines in PowerPoint. And this graph actually shows at that conference I was referring to before, which is the biggest digital technology conference on the planet, Autodesk University in Las Vegas, that happens every year in November, that between 2012, which is as far back as I have numbers, until the pandemic broke out in 2019, the increase in Revit-related presentations, labs, roundtables increased, but the number of presentations or sessions at that conference that contained the word Dynamo increased more. So relate in between the number of Revit sessions that also include the number of Dynamo sessions greatly increased from about 0% in 2012 to almost 30% in 2019. So that means that almost every third Revit presentation at Autodesk University in Las Vegas had some Dynamo to it. And a final graph that reinforces this is that with every open source, freely available hacking tool that the community just grabs and takes and makes it into their own, there's usually a forum where people help each other out. Grasshopper has a forum, Stack Overflow is a forum, and the Dynamo forums exploded when this was introduced back in January 2014. Almost 7,000 people signed up for that forum like in the first weeks. and then it has just increased at different rates. And actually between 2015 and I have data until April 18th, but I know also that this has increased, and today it's more than 42,000 people registered on the forum. So it's becoming a mainstream, it's becoming a movement. Hundreds of thousands of people are doing this on a global scale. I'm going to share with you 3 examples of where this has made an impact on the design scale. Number 1 is the company that we work with, Renzo Piano Building Workshop in Geneva, Italy, and Paris, France. They designed and have been designing. This project has actually been going on for some time. It's the Academy Museum of Motion Pictures in Los Angeles. And this was opened in September this year. And I don't know how much you know about BIM, but most BIM products exist for there's a very simple reason why we want to do anything in BIM is that it's smart to have information in a central database that several people can access. You know, we moved from CAD or like DWGs and Rhino files to BIM so that several people can be in the same database and work on the same underlying data, updated database at the same time. But in all BIM platforms, it's really difficult to model stuff like this because they're all created like with parametric modeling in the mind so that the wall has a height, it has a thickness, but these walls, they are very difficult to model with these tools. So the architects at, Paolo is his name, the architect at Renzo Piano, he created four geometrical models and scripts that automatically responded to the constraints of the building. Vertical grids, horizontal grids as in levels, and then 4 different surface models that where they calculated the intersection between the grids and the surfaces, and then automatically placed all the ribbons, the interior acoustic panels. This is a movie theater inside there. And precast concrete elements, catwalks, and the dome structure on top of it into a completely adaptive model so that if a radius changed or something moves or a grid moves, the modeling of the BIM is not slow, it's fast. It's instantaneous and parametric. So this is one example. Opened in September this year. You can see it in Los Angeles if you go there. Another example is a project that I worked at Snøhetta, which is the new Le Monde headquarters in Paris, France. Same problem, a double curved glass surface. It actually has eight facades. Some of them are straight, some of them are tilted. There's a conical facade on the other side of the building that you're not seeing, and there's a big spherical cut into the shape of the building that is really, really difficult to model and iterate over in most design tools. So in this project, we did more or less the same as Renzo Piano architects. We created these parametric models that did intersections between the horizontal planes, the vertical grids, and the surface model, placing BIM elements programmatically. So we didn't place a single one of those 21,000 glass panels. It was all instantaneously modeled when we changed some parameters or moved some grids. And this is smart. It saves time and frustration. In addition to this, we proceeded by manipulating the types of different panels. Each panel is 1.35 meters wide and 340 centimeters high. And they all have different properties relating to the reflectivity of the glass, the thickness of the glass, the width of the glass, the placement of the glass panels. And there's a reflective interlayer in between some of the glass panels. And this was all manipulated using scripts. So we built a series of scripts, 5 scripts that all changed and randomized some combination of parameters to make the expression of this glass surface look organic and random at the same time as it was optimized, because there's no transparent glass panels in front of the slab edges, and there's a higher degree of transparent slab edges in the area where people look out on to Paris. And the building was completed almost a year ago, and it's located right next to the Seine with the Eiffel Tower in the background, and it's a beautiful emotional experience for me working on the project to come with the metro over the river and see this what I think is a piece of art and a beautiful structure in Paris. So that's two examples with complex geometries, and this is where it usually started with people who were hacking their BIM and creating these like visual programming interfaces for their own design workflow. But I will share with you a last example, which does not have any complex geometries. It's just a big, very special project for a lot of Norwegians because it's the government quarters in Norway that were blown to pieces by a 950 kilo fertilizer bomb by the terrorists on 22nd of July 2011. This is a picture on that day. This is the main government quarters in my country. I live there in Oslo. It's a kilometer and a half from my house. And it was a gigantic thing. I'm sure a lot of you will remember this when it happened. I'm not going to talk so much about the incident itself, but needless to say, we needed to build a new government quarters. And there was a big competition and lots of iterations, multiple competitions actually, and the team that eventually won presented an idea like this, remaining the big main tall building from the 60s in the middle and then building pretty straightforward, like basically just vertical extrusions of the plot and then floors, 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 similar facade, but still maintaining the government quarters in the same location. And this is, needless to say, a very, very important project for my country, for me, and for everyone in Norway. Not just because of the emotional importance of it, but also because it's located smack downtown Oslo. It's very big, very complex because of security regulations, and there's roads going underneath the ground. But why am I talking about this? Is that on this project, I've been working on it the last 4 years, we took BIM hacking from the complex double-curved facades to like everyday work. We built one workflow that solves maybe one of the biggest challenges that we have with BIM today, is that BIM was created to avoid 100 million drawings. So you have one BIM model instead of 100 million drawings. But what we end up in a project like this is not 100 million, but at least like 50, somewhere between 50 and 100 models. And one BIM model is a database. So when you create 50 databases who are not interlinked, it's a problem and a lot of wasted time, because all of these buildings consist of several models. So we built a hacky workflow that every night at 1 o'clock at night opens up all of these models and makes sure that they are all following the same standards, that the line thickness is the same, that the door handle is the same, and all of this on a micro level. Solving that problem of having 50 databases that are not connected. We also build automatic scripting of imports and exports. So the engineers are using a tool called Tekla, the architects Revit, and the interior architects are using ArchiCAD. And every night they all export like IFC models from all of these models every night, and then we import it so that when the entire design team comes into the office in the morning, all work underlay is finished and they can just start working. And the last scripted workflow we did was to follow the same principle of the database, just across multiple files, because we have fire engineers, acoustic engineers, security engineers have a very important job on this project, and door technical guys who are managing information on doors. And they have their models, and then they enter information on their models, and then our scripts open these models at night, copying parameters between elements so that you have a single source of truth. Basically, fire engineer just adds fire information to one door, and it goes out to all the other disciplines who need this information. And this is pretty interesting because we have moved from just using these visual programming scripts, the BIM hacking, from doing like complex facades and into a more everyday job on every project. There's some very clear reasons why we're doing it, and the Norwegian government or the state of Norway have hired people to make sure that we, by implementing these technologies, increase efficiency. so that architects are not spending their time clicking file export, but designing buildings. And also, we want to increase quality, not just of the final product, the building itself, but of the model deliveries, the work underlay production. And on this project, we're going to be modeling from, constructing from models, and then it's really important that we have high-quality models. And the base reason for doing this is two. One, of course, you want more or better buildings for less money, which is the brain reason for doing automation. But there's a second component to it that I find equally interesting, and that is the emotional reason for working like this. It feels meaningless to do manual work when you know it can be automated. I had an interesting conversation yesterday about a farmer, like from 1,000 years ago, that was hacking the earth like this every day. And then his neighbor buys a better hack, or maybe a few hundred years later, a tractor that does this automatically. And then what happens is that the guy who's hacking the earth, he's looking at his neighbor and going like, why am I should probably be doing this. And that is what is happening with humanity when we are innovating. So what was considered a meaningless job 10 years ago, or what was considered a meaningful job 10 years ago, is maybe not considered a meaningful job today. This moves. And I found a fantastic illustration of this on Twitter when I was Googling material for the presentation, is that if we're assuming that we're all working with like good working conditions and not bad working conditions, but you can categorize jobs into like meaningful jobs and not so meaningful jobs. And this moves. So 20 years ago, for an architect, maybe it made sense to do click, 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 but it's not anymore. And the funny thing about this is that it just happens. You don't need to do anything. These people will come straight out of architectural school and just already know these tools, and they will sit down in your office and they will just start writing scripts. And then when we're done like discussing whether it's good or bad, or like they're just doing it. So looking a little bit to the future, what I think that I'm reflecting when I'm reflecting on what I've been through, like I've been doing this now 10 years, is that first of all, when a whole generation of architects and engineers are building tools on a daily basis as a natural part of their work, it's their left arm, we are going to have a massive increase in tools. This, of course, will have a downside. It will be very difficult to know which tool you should choose for which job, because there's like 100 million tools. But some of these tools are going to be really amazing. So when we have a whole generation of architects making architectural tools, some of them are going to be really amazing. There's a new job on the market. It used to be called a CAD manager, then it was called a BIM manager, and what we now have, an official title on the project, the most high prestigious project in Norwegian history. There's an official title that's called the BIM Systems Developer. That is going to happen on every new big project in Norway in the coming years. We're not going to start any project without some person being responsible for BIM hacking. This is true. The next hospital will have a systems developer on it. And as I said, what is considered a bullshit job will change. Final reflections on this is that there's actually, I found a website when I was doing research on this. It's called Scratch. It's the biggest free sharing community of code for kids. Scratch.mit.edu, I think it is. And apart from the fact that the amount of comments just blew through the roof when the pandemic started, probably because a lot of kids were sitting at home and they were like starting to engage with each other's coding projects, there has been an increase in the number of kids who program. And this is an American platform, and I'm sure you're going to see the same in schools all around the world. My kids are now learning algorithmic thinking in their school. And the average age of these kids is between I don't know what the average is, but the peak is around 11, 12, 13 years old. And if you remember the previous slide, this started around 2014, 15, 16. And in not so long time, these people are going to start, probably they all have started architectural school, engineering school, are contractors, and they are going to hit the workforce this year, next year, the year after. And then what will happen then when we have a whole new generation of kids who code as a natural, like as natural as you move the mouse and keyboard? That I find extremely fascinating and interesting. And thank you so much for your attention now.